don't need this thing on anymore. Okay, we're gonna go through those last two questions on lesson 6.6. I'd actually like you guys to open, everybody except for Ricky and Zach, to open up 6.6, and I'll do, even if you've already completed it, I'll do a couple of different examples to help anybody who's watching the video with their specific examples. Because I'm guessing that Savvis, that Savvis only generates a certain number of those types of problems, like 3 or 4. And so if I hit a couple of them, then I'll hit everybody's. Starting with yours. So this is number 3, right?
Yeah.
Okay.
9x squared.
9x or what?
9x.
9x squared, okay.
Plus 21x.
Plus 21x. Quiet back there, we're taking notes. Even if you've already completed this homework, we're still learning from this.
Plus 10.
Plus 10? Okay. Okay, so everybody open up your notebooks to the steps. I believe there were 7 of them when we wrote all of these steps out. Let's go through the steps. Ricky, would you like Jared to help you with your FLBS today? Because that would be a good resource. Do you want to work out there with him? Sounds great. He's doing FLBS, like post recovery from last year, so it's pre-algebra.
Okay.
So we could just help him work through that.
Right here or outside?
Yeah, you guys can go out with the alien. And Zach, do you have anything you need to like work on math-wise? Alrighty, so what is the very first step of solving these types of problems? Yes, let's try to look for a GCF. No? What? Yeah, the only GCF it has is 1. If I pull out a 1 and divide by 1, it's gonna stay the same. So factoring out the GCF of 1 is not gonna help. Therefore, we can just check off the GCF step is already done. So we can just move on. What's the next step?
Multiply the AC to the power.
Okay. So what does that mean for this problem?
9x squared times 10.
I'm glad you said that. Above this, I'm gonna write the standard form of a quadratic expression. Now I want you to tell me which, what?
There is no product?
No. Now I want you to tell me what is A of this?
9x squared.
Let me draw some arrows and I think that'll help you. Or actually, I'm gonna circle things.
Oh, 9.
Yep. That's why in the form, like the standard form of a quadratic expression, it includes the x squared to show that A is only the coefficient of the first term. It's not the x squared. The x squared is x squared. The A is the coefficient. Now for C, there is no variable, so it will simply be that number, okay? So now again, tell me how to multiply A times C.
Be 90.
Right, it would be 9 times 10. Earlier you said 9x squared times 10, but you weren't remembering that the A part is just the coefficient part. It does not include the variable. So A times C would be 90. Now, what do we need the 90 for? And it's okay to look to your next step if you want.
To find the... use it to add to get the sum to be...
Okay, so my question was,
I don't know.
what are we using the 90 for?
As the product?
Yeah, the product of what?
A and C.
Well, the product, we found 90 by getting the product of A and C, but we're using 90 to get the product of what?
B. 21.
No. The answer to my question is not a specific number. We're using 90 to get the product of two numbers that also add to get. You already read it, but you can say it again.
21.
Yep, to get B. So which would be 21. Okay, so what we did here, let's back up for a second. We factored out our GCF, right? Which was a step that we could check off without actually doing anything, yes?
I don't want
You don't feel like you need this? So you know how to do it? Okay, then walk me through the rest of it real quick, and then you can get water.
Gotta find the two terms and match the 90 and the 21.
Okay, what are they?
10 and 9. Oh wait, no.
This one's hard, you might want to use your calculator.
Just like your phone's on the camera.
Oh no, it's okay. This is a hard one.
15 plus 6. I mean 15, 6.
Okay, is 15 times 6 90? Okay, good. I didn't know that, so that's why I needed your help with your calculator. So 15 times 6 is 90. And then 15 plus 6 is also 21. I love that everything's positive here. That makes it easier to not have to worry about what's negative, what's positive. Now, what do we do with our two numbers here, the 15 and the 6, Abs?
You kind of know.
What do we do? Like, just tell me what to do.
Do x and then x plus 15 and then parentheses around both. And then
Okay.
X plus.
So I think I know what you're saying, but I'm gonna say it in like the more like step-by-step way. You're gonna take your two numbers, the 15 and the 6. We're gonna use these numbers to split up
Oh, yeah.
the 21x.
Mhm.
I'm gonna split up 21x into two addends. Addends mean two numbers that can add together to get that sum. If these can add together to get 21, what can add together to get 21x?
15x plus 6.
Yeah, 15x and 6x. 15x plus 6x will get 21x. So if 21x needs to be split up into two addends, I can use these two addends to break it up. We're just rewriting it so that we can split them up and make two separate teams. Now, commutative property of addition tells us that I can write this either way. I can also write this as 6x plus 15x, and that will also get 21x. Which order do you think will be better when I consider what's on the left team and what's on the right team?
The 6.
The 6x is gonna be better, very good, on the left team because it's gonna give a really good GCF. It has like a really good GCF bond with that one. And then the 15x would do really well over here because they'll have a good GCF. If you switched them around, you'll still get a GCF on both sides. So it doesn't really matter, but I think I like these pairing up together on a team and these pairing up together on a team. It's gonna make it a little easier. Now that we have our two teams, we're going to work with one team at a time. Let's look at the left team. What are we gonna do? Identify the GCF. And we're gonna pull that GCF out, or we're going to factor it out, meaning the GCF is gonna be a factor, and then we'll get the rest by dividing by the GCF. What is the GCF of these two terms? What? That's part of it. This doesn't have an x squared, so just 3x. So 3x is the highest number, or the greatest number, that they can both common be divided by, factor. The highest number, or the highest term, greatest, that they can both common be divided by, factor. Greatest common factor. So when I factor out my GCF, that becomes one of my factors, and when I divide, I get the rest, or my other factor. What do I get here?
Oh, sorry, we're dividing. 3x squared.
How are you getting x squared?
I don't know.
Okay. Well, let Emily think about this for a second. What is the rule for dividing x squared by x?
Just be x.
Yeah, it would just be x because.
It doesn't have a square. It's not squared.
Well, tell me what like the rule would be like. For example, let me give you like a totally different one. What if it was like x to the 7 over x squared? What would that quotient be? X to the 7th divided by x squared. What would the rule be? You can either tell me what the answer would be or tell me what you would do to find the answer. X to the 5th? That's correct. Because when you have the same bases being divided, you subtract the exponents. 7 minus 2 is 5, so that's correct. Subtract the exponents, but there is no exponent here. What is it? 1. 2 minus 1 is 1. So it would be x, 3x. 9 divided by 3 is 3. And then x to the 1 power, but we don't need to show that 1. We just use it when we need it, erase it when we don't anymore. Okay, and then over here we have positive 6x divided by 3x.
Plus 2.
Plus 2.
Because you just divide.
6 divided by 3 is 2. Somebody tell me why she didn't say 2x.
Because the x's cancel out.
Yeah, very good, because the x's cancel out. This is probably one of the most common mistakes I see, is that they'll write 2x for this because they look at those and they get it confused with the like terms when we're combining like terms and we have the x at the end, we keep the x, but this is not combining like terms, this is dividing, so the x's cancel out. Okay, so we have factored out one of the teams. Let's go to team right and factor this out. What's their GCF?
5.
5. Why is it not 5x?
Because the 10 is not
Right, because one of the terms doesn't have an x, so it can't be a common factor. So we're going to factor out the 5. Now I'm going to write a positive 5 here. That's very important. We're factoring out a positive 5, so we write positive 5. It's going to help us in the end. Okay, then we're going to divide and get the rest. What do we get?
3 plus.
What?
3 plus 2.
Nope. Close, but
Oh, 3x.
yep. 3x plus 2.
Matchy, bobo, matchy.
Matchy, bobo, batchy. When we get matchy, bobo, batchy, we celebrate because we have found one of our final binomial factors. Matchy, bobo, batchy, bobo, batchy. Okay, 3x plus 2 is one of our final binomial factors. And you can check your notes for this one. I think it's the last step.
Yeah.
What is the other binomial factor?
Undistributed. Josh, it's your, GCS.
She's right about the undistribute part because technically we are undistributing, which means we are grouping the binomials back together. And you are also right, Emily. It is the combination of the GCFs. This GCF and this GCF make the other binomial factor. When we do that and we are grouping these back together and putting this back in its spot, we are undistributing. So that's another. Yeah, you can get water. Thank you for helping. You can get a big old drink of water. So that's number 3. Number 4 is going to be a lot trickier. I wish I had an extension cord for. Let me know if it does anything weird, like stops recording or anything or shuts off. Number 4 is much harder because I believe it involves factoring out a negative in one of them. Yeah.
I don't know what this one's going to. I don't know what's going on. This. Just tell me.
Do the figures appear to be similar? It doesn't. Oh. It appears.
It's smaller than 1/2.
No, they do not have the same shape. That's not it. Yes, they appear to be similar. That could be it. They appear to be similar. It appears that if the figure on the left were scaled by 1/2, the image could be mapped onto the figure on the right. That's possible. I don't know if that would be cut in half. That looks a lot smaller, but.
I said a 4th. There's a 4th.
Oh, a 4th? Yeah. It's definitely not C. Did you choose C?
No.
Yes, they appear to be similar if they were scaled by 1/4. The image could be mapped. Yeah, that, I would say a 4th because it's much smaller.
Yep.
All right, so number 4. Okay, go ahead.
2s squared
2s squared
minus 9s
minus 9s. Oh no, that negative is going to cause all sorts of problems. We'll figure it out.
plus 9.
Plus 9. Did I copy that right? 2s squared minus 9s plus 9. Okay, we're gonna go through all the same steps. Nothing's gonna be different except for one tiny little part towards the end when we're factoring on our teams. But let's just go through the steps. What's the first one?
My GCF.
Okay. Done. There is no GCF. Yeah.
Multiply A and C.
Okay. A times C would be 2 times 9, which is
18.
18. Good. What do we use our 18 for?
The product.
Yep, the product of 2 numbers. That will also add to get B, which is negative 9. Okay. This is gonna be where the rubber meets the road.
Could this be negative 9 and
Negative 9 and negative 2?
Oh, wait, no, never mind.
Okay. Is it still recording? Okay, good. Does anybody know what 2 numbers this would be? It smells like they're roasting chicken.
5. I know 5, 9, and what was it? 2.
But how would I get negative 9 with that?
7. Negative 2 and 9. No. Oh, negative 1 and 9.
But how would I get 18 as a product with those? Guys, what we're supposed to be looking at first is the factors that are possible to make 18. 2 and 9 is possible to make 18 as a product. Is it possible to make negative 9?
3 and 6.
3 and 6. Very good. Be more specific.
Negative 3 and 6.
Nope.
Negative 6 and 3.
Nope.
Both negative.
Both negatives. Negative 3 and negative 6. Negative 3 and negative 6. Cancels out the negative, makes the sum negative. That works. Now, we're gonna break up our negative 9s into these two terms. Now remember, we need to get a negative 9s, so we need a negative 3s plus a negative 6s. Any specific order that would make better sense for team left and team right? Which one do you think would be better on this team?
Negative 6.
Yes, the negative 6s. So I'm just gonna write minus 6s right here, and then I'm gonna write minus 3s right there. Now they're on their appropriate teams. It's gonna make like some nice balanced teams. And this is the negative that's gonna just cause all sorts of problems. We'll get there in a second. Let's do team left. What's the GCF?
2.
That's half of it.
2s.
2s. We're gonna divide by 2s, and we're gonna factor that out, meaning that is one of our final factors, and then the rest would be 1s, good, so just s.
Minus negative 3s. Oh, sorry,
Negative 3, good. So nice and simple, 2s times s minus 3. Now, I'm going to walk you through the wrong way to do this, because it's not technically wrong, but I'm gonna show you how doing it the way that we've been doing it is going to not cause a matchy-matchy boba-batchy, and that's gonna make us sad. And I can't hit the gritty if we don't get matchy-matchy boba-batchy, okay? So first, we're not gonna get matchy-matchy boba-batchy by doing it the right way, but missing something. Okay, so let's just do it the way that we've been doing. So what's the GCF of these two terms? 3 is correct. If I divide by 3, I'm going to get a positive 3 as my GCF. And what do I get for the rest?
Negative 1s.
Good. So negative s.
No, you won't. No, you didn't. Plus 3.
There can't be any there can't be any gritty hitting yet, because these kind of look alike, but they're not the same. A positive s minus 3 and a negative s plus 3. That just isn't the same thing. But we didn't do anything wrong. We just didn't get a matchy-matchy boba-batchy. So what we can do is say, hey, if I need a positive s and a negative 3, but I have a negative s and a positive 3, I basically need to just flip these signs, right? Okay, I guess we can call that flippies. If I just need to change these signs, how do I change these signs? What can you do to change signs?
Oh wait, never mind. I was gonna say this should be the positive.
I know where your brain is trying to get there, so you're getting there, but the way that we can get the opposite signs is if we were to divide by a negative 3.
I had a feeling it was going to be negative.
Yeah. So what we're going to pull out, even though you might say, but hey, negative 3 isn't a common factor of 9. And it kind of is. Because if you think about it, positive 9 could have a factor of negative 3, right? So it could be a common factor of positive 9, because negative 3 times negative 3 is 9. So you can call negative 3 a common factor. You might not notice it at first, but if you're trying to pull out a negative, you could say, sure, negative 3 is a common factor of negative 3s, and positive 9. We can divide 9 by negative 3. Okay, so if I pull out my GCF of minus 3 or negative 3, and I divide each of these by a negative 3, what do I get?
Your phone.
Oh, so now it's got like 5%.
5, negative 3.
No. What do I get when I divide
Oh,
negative
wow.
3s by negative 3?
S.
S.
I thought that was a 5.
Oh. And then we have a positive 9 divided by negative 3.
Negative 3. When do we hit the 20?
Matchy, bobo, matchy, bobo, batchy. Okay, that means that when I get my matchy, that is one of my final binomial factors. What is my other binomial factor?
Negative 2s minus 3.
Good, my GCFs. 2s and a negative 3 would be 2s minus 3, and that's it. If I were to go ahead and FOIL this, I would end up with that final trinomial. I'll be right there, exactly.